So I might try to do one more question actually. A happy number, it's a math problem. So write an algorithm to determine if number n is happy. A happy number is a number defined by the following process. Starting with any positive number, starting with any positive integer, replace the number by the sum of the square of its digits. Repeat those processes until the number equals 1, or it loops endlessly in a cycle which does not include 1. Okay, so we need to see if we're in a cycle. So one of the ways that we can see in a cycle is that if we end up at a number that we have seen before, then this is a way that we can see a cycle. For this, I'm thinking of using a hash set. So we can store each of these inside a C and hash set, and if we have seen the number before, this means that we're in a cycle and we will return none. But if the output is equal to 1, we'll be able to return true. So first we're going to have a set of we'll call it scene, and then this is going to have all the numbers that we have added up. So I'm thinking we can have a recursive function. Recurse. It's going to take in a number, integer. It's going to output a bool. So for numbers, we're going to go for digit and number. Then we're going to do, so we're going to do not the product, but we're going to do a output number. And this is going to be, then we're going to have right here actually output equals 0. For digit and number, we're going to add it to our digit. So output equals digit times digit. And lastly, we're going to check it here. If output is in scene, we're going to return false. Else, we're going to add output to the scene list, scene.add.output. And then we're going to call the same function with this new output. So let's see, let's run this, let's see how it goes. Int number is not iterable. Okay. Then let's cast it to a string. And then store it times it by an integer. Okay. So we're not actually, so it's 1. So we should be getting, so it does return true. Whoops, we just need to return the output here. Yeah. Cool, nice. So that's a happy number. Oh, that's a nice one. I like this one. Let's see, is that an easy question? Yeah, okay. Can we actually, so we can use a Floyd cycle finding algorithm, I guess. This is like finding a cycle in a linked list where we have a slow pointer and a fast pointer, where the fast pointer moves every 2, where the slow pointer will move every 1. And if they ever end up together, that means that there is a cycle detected. And for a cycle, this will always happen. So I guess we can do that to use a space complexity wise. So yeah. Cool. And logarithmic time complexity. Should we try do another one? Oh, so this is using a stack. Yeah, this one was quite fun. I remember doing this. Oh, majority element. I remember this one. This one was this one was an interesting one, I think, where we only look at half of the array. No, the majority element would always show, which will always have more than half of the array. That was the assumption here. So I think we just count it. We iterate through it, and then but in O(n) space, I can do it in linear time, but what about O(n) space? How would we do it in O(n) space? I think we need like a hash map. Let's see. It's yes. So you have a count for each. So for each number you count, you go up, then you go up, you go up, go up. But then you subtract if it's not. And if it's ever not, if it's -1, that means that it's not going to be this, right? Wow. So then you move on to the next count that you see. Hmm. Find the celebrity. What is this? Task scheduler. This sounds like a concurrency question. Okay. But yeah, anyways, that was the happy number question.